Hello, fellow data analyzer. Let's start another topic from the field of data analyzing with focus on neural network. Today we are gonna tackle the 8th session on neural network. And as I said last session, we are gonna do it with some sort of focus on R. And in fact, we are gonna start applying the software and doing our data analytics for the first time. That is absolutely very necessary. And we will do it with neural network. We are not gonna talk about R programming as the first area of focus. No, our focus is on neural network, and we are going to use R to do the neural network analysis that we have. It's very different. For example, when we had Java class together, our focus was Java programming, and we do everything in learning different aspects of Java. But with R, we are not going to do this thing this semester. I wish I could, but due to the time, we cannot do it. Maybe in the future curriculum, we are going to make it possible. So we are going to tackle R as independent programming language like Java. But this semester, we are just going to use it as a tool to do neural network analysis, because after learning about the basics of neural network, it would be good to practice it and see what happens in reality when you are doing it. In the previous examples that we have had so far, for all of them, as you can remember, we have examples after each methods, after each technique we learn together. For example, about trees, about KNN and other ones. But with the neural network, it would be very difficult, for example, to run a neural network for 1,000 times to see the results manually. So we have to use a programming language to do that thing, and it gives us a very good excuse to get acquainted to some extent with R. What is R? R is a programming language and free software environment for, that's the very important part that make R a special kind of language in comparison to the other one. It's for statistical, computing, and graphics. The R language is widely used because it is designed for statistics. So it is widely used among statisticians. That's one of the very close fields to data analytics, as well as data miners. That's the reason R always considered as a very particular, special programming language in the field of data mining. It doesn't mean Java, Python are not important in this field. Absolutely. For example, when you know Java, it's very easy for you to learn other programming languages. But since Java is a very expert and technical type of programming language, they don't consider it as a normal expectation from a data miner. In fact, a data miner who knows Java programming, that's an excellent thing. That's not a minimum requirement. So, but since R is very easy and you can learn it quickly, it's one of the things that they at least accept a person who knows R, who comes and apply for a data mining job knows R. So when they say they want R, it doesn't mean they don't want Java. They don't have that high expectation. Of course, for example, when you interview someone and he comes and say that I'm very good and fluent with Java, of course, that person knows, the person who is very fluent and good with Java can learn R like a piece of cake, very easy. So I just wanted to tell you about that thing. And don't take for granted that now you are very good with Java. So of course you cover that part. So when you go somewhere and they ask you about what's your knowledge of R, make sure you make it clear for them that you are very good with programming, Java and Python. So when you are good, especially with Java, it would be very easy for you to learn R. But again, I'm saying that the reason that they say that, do you know R? It's the minimum things. It's not difficult things, but they say that about R at least as a programming language. When you know Java, that's great. That's a very high expectation that you already satisfy. But although all the things are true in the field, take your time and learn it. And especially this semester that we just gonna start it and do some practices in R, you get the idea first how much easy it is in comparison to Java. But take your time and add it to your resume as a good contributor, as a good enhancer of your job application. Okay, so R is a programming language. It's a free one and mostly used by data miners and statisticians because it's very easy to use for the statistical and mining applications. And if you know other programming language, you will notice that how easy it is and you will love it. As I told you, we are not gonna learn R as an independent programming language. We are gonna use it as a tool for doing neural networks. So the answer to this question, that what is the first model we want to create with R, is a neural network classification model. We are gonna make it and we are gonna use some sort of real data, and you will see how much helpful R is in doing all this stuff. You know CSV files because when we studied Java together, we spent several sessions in discussing CV files and their advantages over other spreadsheet files. What's happening today? Over other spreadsheet files. The same thing applies here to R, because now when we want to give the data and we want to analyze that kind of things, we are gonna use spreadsheets and we are gonna use CSV. As you can see in the slide, if you are using R, you will likely to read in data at some point. Because for example, now, we are gonna give data, training data to the neural network. For example, they are 1,000, they are 1 million. They are big numbers, so we are gonna handle that things with the great efficiency. Spreadsheet softwares like Excel, CSV, and this type of things are giving us. And when we are using this type of spreadsheets, okay, CSV is very good item. While R can read Excel, XLS, and XLSX files, these file types often cause problems due to the same reasons I discussed it last year in the Java class. Comma-separated files, or CSV, are much easier to work with. It's best to save these files as CSV before reading them into R. So it was some sort of introduction on the type of data that we are gonna use. And let's start activity 1. Download binary.csv file on Canvas and save it in your working folder. The working folder is the folder that you are gonna save the files that you want to work with over there. So just have, it's not the particular things, it's not very special things, that's to give order to what you are doing, have your work more organized. So just create a folder and download that binary.csv that now is on Canvas into that folder, and check the file and try to guess the classification problem we are going to perform. See, here, it just wants to make you more instinctive. Or in fact, it tries to work on your intuition. That when you see a set of data, can you guess what type of classification problem we are going to do with this type of data? There is no answer for this. It is just a discussion type of question. So when you download the data, just take 1 minute to 2 minutes in checking the data before I start discussing that things, and we proceed over that. But before, try to get a guess over what type of classification model could be developed over such data with neural network. And do you have R on your computer now? Okay, great. Working folder could be anywhere on your computer. Just you need to know the address. That's it. I'm telling you, R is super easy. Okay. After 2 minutes, we start checking the data. Now it is data that you just downloaded. Yes? Okay. This is the data. Apart from the number of data that it is 400 cases over there, you see here 5 columns. Now I'm telling you, we are now working on the intuition that when you see a set of data and it asks you, try to guess what type of classification problem we are going to have here. Try your best to get a good scenario, a real good scenario over this. The first column is no number. It's something like ID. last semester with informatics 450, we learned that this type of things, IDs or like this, cannot be a feature because they have no effect on the outcome. So quickly ignore this thing. Okay, after that, we come here to see we have a column that is admit, GRE, GPA, and rank. We notice that it has something to do with admission, universities, and things like that. GRE, which part of this problem looks more fitted to a classification as the output? We can see here rank 3, 3, 1, 4, 4, 2. It could be a classification. But here with GPA, no, it is not a classification. We have any number, imagine they are GPA, So they are, maybe they are a good option for prediction, but they are not a good option for classification. The same things for GRE that you see. So when it says it's a classification problem, the outcome could be the rank. So it classifies the input as rank 3, 3, 1, 4, or anything, or it could be the admission. In fact, it gets GRE, GPA, and rank to classify that case as admitted or not admitted. It would be the scenario. But I tell you, admit in our case would be outcome. And these three things are the features that we have. What does it mean? It means in the model, we give the GRE of the person. For example, we want to predict. We have the real cases. They show us 14 applicants. They give us their GRE, they give us their GPA, and they give us the rank of their school in the region, or the level of their school in the region. According to that thing, we predict if that person could be admitted or not admitted. The base of many of the intelligence systems you see around yourself, they quickly tell you if you are eligible for credit or not, you are eligible for applying or not. All of those things are based on such, not simple, they are brilliant, they are excellent. But after we know about the mechanism, about the anatomy of these systems, yes, they are easy. Okay, they get the rank GPA, GRE, and they predict the admission. That's it. It's the problem that we are gonna tackle. It's the prediction model that we are gonna make. Our model is simple one because we have only 400 training data. We have only 3 features and 1 outcome. But if we had 3,000 features, if we had 4 million training data, the process is still the same. It depends on the power of the computer, how much quick it can give you the results. So it is the scenario that I just told you. But activity 2, that now it is serious, and I want you to do your best. And because of the special type of this class, you see above, you don't see the next slide is the answer. So we are gonna do everything together. So always try to keep up. I try to keep the pace in a logical way. So you are doing it, and also from time to time you check the answer with what you see on this slide or with the lecture that you hear. So just be active during this 50-minute lecture. So it says continue activity 1 by drawing a typical neural network that fits the scenario. Now, it doesn't ask you to train a neural network. It just asks you to build the structure, build the neural network that can fit the scenario. Go ahead. We have three features: GRE, GPA, and rank. And rank is the rank of the school. And the outcome is admission. Don't forget that when you don't consider hidden layer, your model becomes very easy and as simple as linear regression. So make sure you put hidden layer for that. And also we had some general points about the structure of a neural network. That how many hidden layer is the best. When you are done with your structure, you can check the structure that you can see in front of you in this slide. I'm 100% sure you did it correct. Even I'm not saying 99%, 100% sure you got the idea about the neural network structure. And you had in your mind, even if there are some trivial mistakes with what you have done, that's what you are supposed to do. First of all, we have three features. So for each feature, we need to consider a neuron in the input layer. So here we have the input layer. We give GRE, GPA, and rank. Makes sense because for each student, you need to give the data. Input layer, you give it. Okay, after that, you see each neuron in the input layer is connected to each neuron in the hidden layer, that we have only one hidden layer. That's a good start. And they are connected. And just as an example, I put the weight over the arc of 14. So we have W14 and like that. Also, we have biased weight, that is theta, that just for example, I put one of them because the rest is similar. And after that, you get the output layer that gives admitted or not admitted. It is the structure. Now you have everything, you have the data, and the only things you need to do now is the training of this neural network. Let's check the first data that we have. Andy, would you please read the, do you have the file in front of you, the PowerPoint, or no, you are checking it with Zoom? Oh, you got it on Zoom, okay. So for the first one, we have GRE 380, GPA 3.61, and rank 3. Admit is 0. Okay, what does it mean? It means that when you want to train it, okay, you give now we have it here better. Okay. Okay, see here, when we want to train our neural network, we give GRE as the first set of data, as the first set of training data. We want to give the first one. Okay, GRE 380, we give it here. GPA 3.61, we give it here. And rank, we give it here 3. Also, we give the admit part that is 0. After that, the neural network start changing these weights to find the best fit between this input and this output. At first, as we said it before, the weights would be assigned just randomly. So it generates an answer, assume the answer is not right. For example, the answer, now the correct answer is 0 because the admission is denied. So assume it gives 1. After that, it starts to change all these weights in a way that this error that generated here become less and less and less. After that, you give the second one. After that, you give the third one. And finally, you get your neural network trained over 400 training data. We want to do all those things with R because it's very difficult to do 400 times giving something, check the results and save things. But with the for loop, it would be very easily being done. And thanks to R, even we don't have to define those for loops because they are defined already. There is a library for neural networks in R, and you just need to entry some of the points in that general structure. And that's the reason I'm telling you R is super easy in comparison to Java, but also more specific for the field of data mining, because as I just mentioned, there is a library, there is a commands pre-written and very efficiently and very good written, very well written codes for doing everything with neural networks. Okay, you save the address in a working folder. Now you want to tell R, go and get that data. First, you need to know, this is the first things that you need to know about R, is how to announce the addresses in R. A typical file address in R is written as follows. That must be in a double quotation mark. Okay, so it is exactly the same as regular addresses we use with computers, just you need to use double backslash and also put them in quotation mark. So whenever you have an address, copy and paste it and just double the backslash and put it in a quotation mark. But there is another way also to get the files with R, with the command of, that we are going to practice all of them today, because they are the very basic things and something that with every R programming you need to know. You can use file.choose. When you use file.choose, it automatically navigates you to a navigation window. So you can, on a graphical basis, Windows-like basis, you can find your file and attach it. And the same way you upload your files. For example, when you want to upload your homeworks or when you want to attach something to your email, you just navigate it graphically to the file. You don't type the address. So file.choose does exactly the same thing, a very useful command that helps you avoid the difficulty of typing the address of your file. You just can do it graphically. It opens up a window with which you can select the file you want to work with. Okay, now you have the address. How you get the file, into R. If you need to read in a CSV with R, the best way to do it is with this command, read.csv. That's it, read.csv. Function reads a file into data frame. Data frame is the expression that we use when you get data from your computer. Most preferable format is data frame. To get it as data frame, that by default it makes it data frame. On our console, type the following command. So now we are seeing the commands that we are going to practice in the next slide. Here you put the name of the file, you put the name of the variable that you want the result go inside, because when you get, when you read the data from a file that is on your computer, okay, you want to save it somewhere in your R. So you put it, define it, and you put this sign. Also, you can put equal for that, read.csv, file address, and the header true. Why header true? When you put header true, we also talked about these things when we read CSV files with Java, but just as a reminder, see, when you say header true, it means that you are telling R, hey R, be careful. The first line is header. Don't consider it as data. So when you put header true, R doesn't get this first row as data. Get it as names for each column. So you put header true. So it means that go and start from the second row. You can put the file address the way we talked about it, and also you can find the address by file.choose. And let's go for activity 3 that we have today, and it is our first programming task or activity in this class. Import binary.csv. Where is it now? In the working folder. Import binary.csv file. You just downloaded into your console by applying the 2 methods just discussed and check the results. take your time. It is your first time working with R. You can also do it without IDE, but I recommend using IDEs because you have noticed the advantages of having IDE with programming. So at this exercise, at this activity, it asks you to just get the data by two methods that we discussed. Okay, my friend, the first approach that now you can see in front of you. In the first approach, it tries to get the file through a direct address, read.csv, open parentheses, close parentheses. Now inside the parentheses, it puts the address. What about the header? By default, it considers as true. So I don't put it anymore also. Over there, I told you about header true because I want you to get the point about header. But when by default, it considers it header true. So I didn't put it. So I just put the address, everything in double quotation mark, and also every backslash now here is double backslash. Okay, now we are ready to run it, and you see, you get the results on your screen on the console. And see, since I told R header equals true, it didn't consider the first row as the data, and it starts numbering the data from the second row. And now here we have it. What would happen if, because in the previous one, as you can see, I didn't assign it to any variable. Pay attention how easy it was, because we didn't say about the types of the variable. We didn't care about if there are strings, if they are characters, if they are any other type of things. We just assign A equal. When I put A equal, R automatically assign everything to A. So when I run it, finish. Now A. That remember, I didn't initiate it with defining the types, for example, if it is table, if it is. Now I assign a table to a variable this much easy. It should give you now a glimpse of the simplicity and awesomeness of this software in learning. That's the reason they said that, okay, you don't know Java, you don't know Python, okay. But at least you need to know this R, this super easy software that it doesn't need any type of computer scientific point of view. Computer scientific, yeah. Point of view. So we assign a table to a variable, and now when I put A and click it, I get the ingredients. I get what they are available over there. And it is because of, if you see only we are getting the result until the 200th row, it's because of the options, it's because of the settings. You can change the setting in a way that you see all the results in a single shot. Now, let's do it with the second way. Read.csv. And here, instead of putting the address, I put file.choose. It's going to make it like that uploading. It's going to make it like that attaching and things like that. We put header true. We could not put it here as it is by default true. Okay, click it. When I click it, you see a window pops up. Oh, you cannot see the window. Yeah, on Zoom, but there is a way for that. There is a way for that. I'm gonna do that now because I want. How did you know that, Andy? Because you said it quickly that it doesn't show. Oh, but you say it practically. Let's me, because I want you to see it. Can you see it now? Yeah, very good. So let's do it again. The reason for error, because I canceled it. Let me copy it. Put it here. Okay. Now read.csv file.choose header. Click. A window pops up and tells me, take me to the file. Okay, here is the address. You see, it is the name of the course, Informatic 451, and slides. It's the address that I have on my computer. And here we have the binary file. So I click it and I say open. Quickly comes here. And see, on the first half an hour of our class, we are doing some sort of advanced commands that we usually do with programming languages. And we got it. So if you want to save it in another variable, imagine it is B, no need for initiation. I just put B and click. It says take me to the file. Okay, it is the file. Open. And you got it. Now you have that table inside B. Okay, B, and now you get it here. That's the way, because it's the very first step to get communication, to get relation between R and the files you have on your computer. And let me now get back to this file that we have. Okay, any question on activity 3? Activity 4, use any of the two discussed methods you like better for addressing the targeted file, but this time with header false, and check the results. Wow, and now it's very heavy rain. And it does heavy rain called showering, or no, shower is not this. Oh, it is lighter rain. What do we call this type of rain? Storm rain. Oh yeah, it's heavy. You put the false and check the results. Since it is a straightforward, I'm not going to show it. On Zoom. But there is a very slight difference with the previous one. Now, when you check your answers, you will notice that it starts with the headers. Even the headers, even the header, no, admit, GRE, GPA, and rank has number. And above the table are new headers. They are called V1, V2, V3, V4, and V5. So whenever your data is without the headers, make sure you are using header false, because of course it affects the results you have. About printing a variable in R, you already know about printing a variable in R. You just put the name of the variable in a line of your code. R, interpret it as a command for printing that specific variable. Remember, for example, for Java, we used system.out.println, and you put something inside it. But for R, just put the things that you want to print. Simplicity is one of the goals in handling, in making R, because they didn't want programming is a challenge here. They want the focus on data mining tasks. But remember, still, according to most reliable sources and people of firm ideas in the field of data analytics, computer informatics, they said that the first most important skill a data analyzer should have is programming. That's the reason Java learning is very important still in this field. Okay, another command that we have is str. Str, you type str, that is some sort of initials for a structure, and you put the object. The object of the R object. The R object definition is much simpler than objects in Java. Anything that you create in R is called an object. For example, now you in the previous slides with the activities, I created A and B. Both A and B are called objects here. So when you want to see a report on such things, you just very simply, str is a compact way to display the structure of an R object, for example, A and B. This allows you to use str as a diagnostic function and an alternative to summary. The goal is to get an output for any R object. Activity 5. Import binary.csv into R and assign it to a variable, then apply str on the variable and check the result. You see what a nice report you get on that thing. Okay, I assign it to A, and after that, str A. We talked about that helps pops up in R later more. And another things, when you finish a line, there is no for semicolon. That's great also. Okay, str A, and it gives you a report. Data frame, I told you by default, it got everything as data frame. That's the most popular data structure, and I recommend it. It says 400 observation of 5 variables, and it also shows different columns: number, admit, GRE, GPA, and the initial numbers. Okay, it's good for today. Thank you so much, fellow data analyzer. And let me tell you, welcome to the amazing world of R. I hope you like it. Have a great rest of your day.